So we're going to try to work number 6, and this one is going to also use the combined gas law equation. We're not using those two parts of the chart. Let's read what the problem's asking us to consider and see what we know and what we can fill into the chart. So a closed flask of air with 0.250 liters contains 5 puffs of particles. The pressure probe on the flask reads 93 kilopascals. A student uses a syringe to add an additional 3 puffs of air through the stopper. What will be the new pressure inside the flask? Well, the flask hasn't changed, has it? So the flask will always be a volume of 0.25. So since that's staying the same, we'll just ignore the volume because it's staying constant. Let's use this idea of puffs to represent our number of particles. So let's put for our initial puffs of particles, we'll put 5. And for our final or N2, we'll put an additional, if we have 5 plus an additional 3, let's put 8 in. Now we know the original pressure reading is 93 kilopascals, and it's asking us to find the new pressure inside the flask. So just like we knew that the volume and particles were in a direct relationship, the pressure is also in a direct relationship with particles. Okay, so we can fill in what we know into the combined gas law equation. We can say that there are 93 kilopascals for every 5 puffs of air, and we want to know what is the new pressure if we change that to 8 puffs of air. To me, this one just has to be cross multiply. So 93 times 8 equals 5x. If I want to get x by itself, I have to divide both sides of this equation by 5. So I get x equals 93 times 8 over 5. So with my calculator, we're going to put in, remember this x actually stands for P2. So with your calculator, 93 times 8 divided by 5 gives us our new pressure. Let me try this. I'm going to try this again on my calculator. I don't like what I got. 93 times 8 divided by 5 gives me as my new pressure 148.8, and these are kilopascals. Now let's check and see what about our significant digits. This answer would be acceptable because it's in to a tenth. But if we look, we have only one significant digit in some of these. It seems odd, but 100 kilopascals would be the correct answer if you were counting significant digits. I do like, for this particular one, I do like rounding to this tenth because it seems to be a way more precise measurement.